Hello everybody, thanks for coming. My name's Alastair Kilpatrick. I'm a bioinformatician at the University of Edinburgh, and for several years I was involved in the development and delivery of bioinformatics training for wet lab scientists. It's my pleasure today to be speaking of our study characterizing domain-specific open educational resources by linking ISCB communities of special interest to Wikipedia. So the aims of this project are to characterise a representation of computational biology on Wikipedia, which is a vital open educational resource. And we aim to do this not just at the overall level, but also to leverage data from the ISCB Communities of Special Interest, or COSIs, to carry out this characterisation at the domain level. And then later in the presentation, I'll share some advantages of improving this representation within an educational setting. So I'd like to begin with a definition of open educational resources. So these are defined by UNESCO as learning, teaching and research materials that reside in the public domain and permit no-cost access, reuse, repurpose, adaptation and redistribution by others. And these are becoming increasingly used in the classroom. And going on this definition, Wikipedia is the largest hub for open educational resources in the world. It's of course widely accessed in general as a website, but also in particular for computational biology. So some articles relating to computational biology are viewed almost 1 million times a year. And in recognition of this, the ISCB has been working with Wikipedia for almost 15 years now to improve the representation of computational biology on Wikipedia. And both the ISCB and the Wikimedia Foundation, which run Wikipedia, have a shared core principle of open access to information and scientific information. So one issue with the coverage of computational biology on Wikipedia is that, as you know, we work in a relatively new and fast-moving field. And so it's easy for coverage in a vital resource like this to lag behind the state of the art. So one potential solution is to link relevant Wikipedia articles with ISCB COSIs. And there are a number of advantages to this. So firstly, it provides the COSIs with a domain-specific open educational resource, a list of Wikipedia articles which are directly relevant to their specific subfield. It also helps us identify underrepresented domains or COSIs, and these could be underrepresented in the term of number of relevant articles, or in terms of the quality of existing articles on Wikipedia. Finally, it helps us identify domain experts who have the knowledge to improve the representation of their subfield in this resource. And although there's a persistent criticism that Wikipedia is not a reliable source, anyone can edit Wikipedia, there's a growing consensus that for academics, it's actually a professional responsibility to edit Wikipedia. And really, it's down to us to improve the representation of our subfield online. So as a first step to linking relevant Wikipedia articles with COSIs, we held a virtual hackathon at the ISCB Student Council Symposium in July 2021. And this hackathon generated a list of around 1,500 articles which are relating to computational biology. We then had volunteers at the hackathon classify each article in the list as relevant or not to each COSI. So the outcome from this event was a binary matrix which links relevant articles to COSIs and vice versa. And this matrix is available online now for download. And in the next couple of slides, I'm going to share some of the conclusions that we've reached through the analysis of this data set. So Wikipedia articles are rated for quality by the Wikipedia editors. So starting at stub class, which is a very small article, so maybe a sentence or two with no references, increasing in quality through start, C, B, and then good article and featured article classes. These final two classes being Wikipedia's peer-reviewed article classes. And we can see in this graph on the left that computational biology articles are of higher quality than Wikipedia overall. So here computational biology is in pink and Wikipedia as a whole is in grey. We also see that the majority of the computational biology articles are start class or lower. So these represent articles which are developing but still quite incomplete, and they might not cite adequate reliable sources. Articles are also rated for importance, so low through top importance. And in our analysis, we find that the proportion of the top importance articles which pass internal peer review is lower than in other related fields. So again, with computational biology here in pink, we compared against molecular and cell biology, genetics, biology, and medicine. And we find that the proportion of top importance computational biology articles which pass this peer review process is quite a bit lower than other fields. So there's a clear opportunity to improve the representation of computational biology in this educational resource. So this opportunity is here overall. What we also wanted to do was drill down a bit and characterise the mean article quality for each of the courses individually with a view to characterising domain-specific representation on Wikipedia. And we found that there's a large amount of variability in the quality between domains on Wikipedia. And we also found in our analysis specific drivers of outlier domains. So for example, the bioontologies COSI is specifically characterised by a large number of subclass articles. So these are very short articles, usually relating to biological databases, which are started but not really filled out any further. In contrast, the variant interpretation COSI on the right has the highest mean article quality, and that's characterised by the largest number of peer-reviewed articles, so in the good article and featured article classes. So identifying these specific drivers helps to identify areas for improving representation overall. So we find that the average quality of articles relating to computational biology is better than that of Wikipedia overall. And this is attributable, at least in part, to the partnership with ISCB through editathons, workshops, and writing competitions. So this photo on the right is from the editathon at ISMB 2017 in Prague. And our analysis of the data from the COSI article matrix shows that the quality scores, both at the overall level and the domain level, are very much dependent on the number of peer-reviewed articles. And so in the paper we highlight a list of candidate articles for promotion to peer-reviewed status. These articles are already of very high quality, but just need an extra push to get into that next quality class. And we leverage the data not just to do this overall, but also at a domain level. And we identify this as a potential task for graduate students in relevant COSIs, particularly fulfilling ISCB core competency N, which is the effective communication of bioinformatics with a range of audiences. So to elaborate on this a little bit further, it's been shown that mentored contributions to Wikipedia improve the quality, the depth and reliability of publicly accessible knowledge in general. And specifically, computational biology courses at Ohio University and University of Texas are now including elements in their courses involving Wikipedia editing. And in 2020, we published 10 simple rules for designing learning experiences that involve enhancing and editing computational biology Wikipedia articles. As a result of these elements, students have reported improvements in their domain knowledge, their scientific writing, and other transferable skills, all of which are linked to the ISCB core competencies. And so we're keen to collaborate with educators who are keen to include these experiences in their classes. So another thing that our analysis of the COSI article matrix allows us to do is identify synergies between COSIs based on articles which are relevant to more than one COSI. So in this heat map on the left, what we've done is compute the pairwise similarities between COSIs based on their shared articles, and then clustered to identify similar COSIs. So we found that the strongest similarity was between the Bioinformatics Open Source Conference and the BioInfo Core COSI. And this is not so surprising because we can see that bioinformatics core facilities often use open source software. We also find a larger cluster which includes the SysMod, the HitSeq, RegSys function, and machine learning COSIs. And again, this is kind of indicative of a field which increasingly relies on next generation sequencing data, which is then analysed using software based on machine learning techniques. So although a lot of these relationships are kind of informal right now, our analysis of the data in this study goes a bit of a way to formalising these relationships. In the paper, we identify some ways to leverage these synergies within an educational setting. So, for example, educators working in one COSI domain could include examples from other clustered domains to place their teaching in a wider context. We also suggest that they could use the article lists that we define here in the dataset as supplemental open educational resources. At the COSI level, these synergies could be fostered by joint conference sessions or a shared seminar series. And we also suggest that on Wikipedia, these synergies could be leveraged to improve the coverage of computational biology through joint editing events, with the goal of improving articles which are specifically relevant to multiple COSIs. So in terms of next steps, we identify some limitations of the COSI article matrix that we generate here. And we intend to improve on these, reducing the subjectivity by involving representatives of all COSIs in future iterations of the dataset, increasing the number of postdoc and faculty level participants, and also introducing an integer-based relevancy scale rather than a binary relevancy scale, because we realise that articles could be relevant to different COSIs to different extents, which is completely natural. We also intend to work to help COSIs improve their domain-specific OERs through editathon events, and we're reaching out to COSI leaders to see how this might happen. These could be through collaborations with the Education COSI and the ISCB Student Council and their regional groups. One final thing that is worth noting is that in the process of our analysis, we found that there's a significant knowledge gap of computational biology representation in non-English Wikipedia versions, which is very important in a worldwide aspect. So in particular, we found that 47% of relevant articles have no non-English equivalent. So there's a huge opportunity for improving representation in non-English languages. So to conclude, Wikipedia is a widely used open educational resource, and I hope I've convinced you that improving computational biology representation in this resource is absolutely vital for us as a field. We've characterised the representation of computational biology on Wikipedia, and we've leveraged data using the COSEs to analyse this at a domain level. We've also presented some advantages of improving this representation within an educational setting, including strategies for data-driven synergies between COSEs. So with that, I'd like to thank you for listening. I'd like to thank the other members of the ISCB Wikipedia committee, especially Farzana Rahman, who was really pivotal in organising the hackathon event that generated the data. Some members of the ISCB, Janet Kelso, Christina Rengo and Diane Kovats, would like to thank as well. The Student Council and the volunteers from the hackathon. And finally, the Harvard Medical School's MBI programme, who generously sponsored some prizes for the hackathon as well. And I'd be more than happy to take any questions. Thank you.